Hello 108 students, Mr. McHugh back with you here. We are going to wrap up section 3.2 and tackle page 3 and finish our journey here with section 3.2 dealing with slopes. Okay, so what's interesting now is you guys understand the slope of a line is rise over run, and now we're going to challenge ourselves in objective number 4 and say, what if there was two lines on a graph? What if you had two lines that were parallel? And parallel means, think of railroad tracks. They never intersect. Think of skis. If you're a good skier, your skis should not cross over. Now I know that happens because I'm on bogus spacing and I've done that a few times. But think of skis, if you could hold them perfectly shoulder width apart and they never touch, they would be known parallel. So most people are comfortable with that. Okay, now railroad tracks is another excellent example, and if you look at this illustration here, if I was kind of calculate the slope rise over run between these 2 points, the slope of this first line and the slope of the second line, if they're parallel, they are the same. They have the exact same slope. Okay, now this is the cases you want to do these. They're going to draw two lines. They're going to tell you about two lines. You're going to figure out the slopes between the two lines. You want to look for case A is, are they parallel? That's the easiest one. When you see the two lines, you figure out the slopes. Use y equals mx plus b. Don't forget m is the slope, and then bingo. If it's the same, you're done. They are parallel. Case B deals with if they're perpendicular. Perpendicular means when two lines intersect. Now this time they're intersecting, but they form 90 degrees. That's what perpendicular means. That's from geometry. Sorry, that's supposed to be a 90-degree right triangle. They form a right triangle 90 degrees, then they are perpendicular. Now the question is, how are we going to be able to determine that? Turns out that if you take the slope of the first line, now let's just pretend it's 2/3. If you figure out the slope of the first line is 2/3 and the slope of the second line is the opposite. Now I used to say negative, but think of opposite. If it's a plus sign, it goes negative. If it's a negative sign, it goes opposite. And it's the reciprocal. Remember, fractions are what we're talking about, reciprocal. So if I would write the fraction 2/3, if I ask you to write the reciprocal, you would write 3/2. Hopefully everybody's comfortable with that. Now, the deal here is if two lines are perpendicular, you need the opposite reciprocal. So now the question is, opposite of 2/3, reciprocal of 2/3 is 3/2. The opposite is from a positive to a negative. Okay, that's what opposite reciprocal means. When you multiply the two of them together, this will equal -1, which I've shown right here. And when you have that condition, you've got perpendicular lines. This symbol is used to represent perpendicular lines. Okay, so we're going to do a problem here to illustrate that. Go through the sequence. Are they parallel? If they're the same slope, yes. If they are opposite reciprocal slopes, then they are perpendicular. If you do not have either case A or case B, case C, the default is they are intersecting lines and the slopes are different, not equal. That's what that means right here. This is the equal sign with a slash through it, not equal. Such as the slope of one line could be 2/3. Slope of the second line might be 5, 6. Excuse me, my dog. Stop it. I'm sorry. Hopefully I can keep going here. My dogs, you think they were guarding Fort Knox here in Garden City. Holy moly. Okay, so without outbursts, let's continue on. And let's try an example. I apologize for that, class. Example 7. Given two lines. Now look, they're in standard form, or close to it. 2y equals 3x minus 6. 2x plus 3y equals -6. Can you find the slope of each of these lines? The answer is yes. Isolate and solve for y. That's the fastest way to do these. Okay, this case, you've already got the y term by itself. Divide by 2 on both sides, and you get y equals 3 halves x minus 3. This is matching up to the form y equals mx plus b. This is called the point slope formula. I nickname it golden. You're going to hear me. Golden meaning this is the form you want to see the equation of lines in. It's y equals mx plus b. It always tells you the coefficient in front of the x is your slope. The number all by itself is the y-intercept. They're easy to graph, and we're going to use that throughout the rest of this chapter. Okay, so I look at the first line 1. The slope is 3/2. Okay, you've done that. Come over, look at the line, second problem. Oops, that's supposed to be copied. That's not too good. Look at the second line. Can you isolate the y? Sure. Minus 2x on both sides. You're going to do this a lot. It's the same two-step algebra process. Move the x term over and divide by the coefficient of the y. So divide all the terms by 3. There's 1y equals negative 2/3 x plus 6 divided by 3. Remember, we divide everything by 3. What cleans up to negative 2/3 x minus 2. Okay, there's the slope of the second line right here. Okay, now the question is, are they opposite reciprocals? Now if you multiply them both together and get -1, you're in good shape. Another way is to visually see 3/2. I might have used this in my example or something similar. Reciprocal of 3/2 is 2/3, but you need the opposite reciprocal. So a positive is a negative, therefore it is the opposite reciprocal. Multiply them out and it does equal -1. The 2 and the 2 divided by 2 equals 1. 3 divided by 3 equals 1. 1 times negative, it gives you -1. Okay, therefore the two lines are perpendicular. Okay, now that's the only example I'm doing here, but this technique will be how you do it. If you happen to get a second line and the slopes are the same, they're parallel. If they're not equal to each other and not opposite reciprocals, then you choose option C, which is that they are just intersecting lines. Okay, hey, Mr. PQ here. I'm going to sign off for page 3 and the end of section 3.2. We're cruising here. When I see you again, I will be starting section 3.3, and we're going to get into some of the meat of this chapter with linear equations. Okay, that's all for now. I'll see you. Bye.